guys, welcome back. We're going to talk about one last type of partial fraction that you need to be aware of. Can I recommend strongly that you read the two examples in the textbook dedicated to exercise 7.1D, as there are a variety of ways you can approach these problems, and I don't have time to do all of them in the video. And it will call back some of your skills in long division of algebra and that kind of thing that we talked about earlier on in the year. Anyway, so improper algebraic fractions occur when a polynomial of degree greater than or equal to n is divided by another polynomial of degree n. So what that means is on top you have at least the same. So what that means is on top you might have something like x squared, and on the bottom you might have x squared. Or on top you might have something like x cubed, and on the bottom you might have an x squared factor. So it's as long as your polynomial on top is going to be higher than that on the bottom. This is what you're going to end up with having as an improper algebraic fraction. So we can split into partial fractions by first doing long division and then splitting the remainder partial fractions into using one of the techniques that we've already covered earlier on. So let me attempt this here. First of all, what I'm going to do is I'm going to expand out my brackets. X minus 2 into x minus 3 is equal to x squared minus 5x plus 6. So over here I'm going to do x squared plus 0x plus 5, and I'm going to divide that by x squared minus 5x plus 6. And I hope you can see fairly quickly that it's going to be 1. So we times it by 1. We've got x squared minus 5x plus 6. And when we subtract that away, we're going to get a remainder. So we're going to have 0 here. We're going to get 5x, and then minus 1 is our remainder. Okay, so we're now able to split this up into a is equal to 1. And now we're going to have, so I've got a, we've done the a bit, now we're going to have bx plus c all over x minus 2 into x minus 3. So I have just discovered what a is, and b, x plus c, is this bit here that we've just worked out. So we've found we've split it into two parts, the whole number and then the remainder, or the fraction remainder left over. So I'm going to do for my next part 5x minus 1 over x minus 2 into x minus 3, and we're going to try and split this up into partial fractions using the techniques that we've earlier done. Well, this looks like a type 1 to me, so I'm going to have to express this as a new a different one this time, over x minus 2 plus b over x minus 3. Now if that's the case, I know that my numerator 5x minus 1 is going to be equal to a into x minus 3, because we're cross multiplying, remember, plus b into x minus 2. And at this point I'm going to say, alright, let's let x equal 3. Now if I do that, I'm going to get on the left hand side 5 times 3 minus 1 is equal to, now a is going to be 0, well, we won't find a, that whole thing will times out to be 0 because we've got 3 minus 3. So we'll just get b into 3 minus 2, which is just 1b. So therefore, we've got 14 is equal to b. And now we're going to work on a. So my next step would be let x equal 2. And when x is equal to 2, I'm going to have 5 times 2 minus 1 equals negative a. And then b is going to drop out because 2 minus 2 is 0. 0 times b will be 0. So we end up with 5 times 2 is 10 minus 1. So 9 is equal to negative a, and therefore a is equal to negative 9. So we are now in a position to write out our full partial fraction. So we've got a is 1, our initial a here. And then we're going to go plus, and we're going to have this a here, minus 9 over, and a is over x minus 2, plus b, which we said is 14, over x minus 3. And we are done at that point. So these, you can see, are a little bit more tricky, involving a few more steps. When you go about doing a question 2, look at the denominator carefully, and you'll see there's a repeated factor in the denominator, because I think you've got x squared minus 1, which is, my hint to you is complete the square there. And for number 3 in this exercise, my strong suggestion is you look at example 8, and that will help you solve number 3. But if you do get stuck, let me know and I'll walk you through it. Alright then, team, good luck!